Where desert heat collides with eternal ice, Nanga Parbat rises like a riddle carved in stone, its valleys and glaciers hiding secrets that a daring 1934 expedition set out to uncover.
It's 2:20 a.m. I'm still buried in the Himalayan Club Journals, century-old field notes from the Himalayas. It's like diving deep into the documented history of the Himalayas from the early 1900s. The journals cover everything, from indigenous wisdom, cultural myths, to epic expeditions and groundbreaking discoveries. These forgotten stories are brought to life by synthetic voices in the Himalayan Journals podcast. Subscribe, zone out, binge, and pass it to a fellow mountain junkie.
Where else on earth does the land rise so fiercely from desert valley to icy summit as at Nanga Parbat? The Indus winds through its bed at just 3,000 to 4,000 feet, while 21,000 feet above tower the ridges and snow crests of the great mountain. Between them lie zones of heat and aridity, then forests, glaciers, and finally the cold heights of ice. It was here, in 1934, that a German expedition set out not only to climb, but to study, to measure, and to understand this northwestern pillar of the Himalaya. The scientific party consisted of Professor R. Finsterwalder, Dr. Walter Raekel, and Dr. Peter Misch. Their work was carefully divided but deeply connected. Finsterwalder undertook geodesy, cartography, and glaciology. Raekel studied geography and geomorphology. Misch examined geology and petrology. Together, they worked across the Massif and its valleys, often at high altitude, carrying out an intensive survey unlike any before it. Previous research had been broad but general. Their aim was to bring modern methods to one limited region and explore it in depth. At the heart of their program was a new mapping effort. Finsterwalder and Raekel carried out geodetic and topographical surveying using stereo-photogrammetry. The survey of India had already produced valuable maps, but at too small a scale for such close studies. So they planned a contoured map of the entire district covering about 1,000 square miles. With the Light Zeiss Field phototheodolite, they established 115 photogrammetric baselines and took 350 survey photographs, most between 13,000 and 16,000 feet. These images would later yield a map at the scale of 1 to 50,000, accurate to within 3 feet. They also measured plumb line deflections at 15 stations, comparing astronomical and geodetic latitudes to understand the form of the geoid. Glaciological work accompanied this, with profiles surveyed on the Raekel and Raekel glaciers. By measuring ice movement through stereo-photographs, they could estimate glacier depth and the volume of ice in motion. Raekel's geographical studies focused on geomorphology, plant geography, human settlement, and daily weather observations. He worked in the Aster and Indus valleys between 10,000 and 16,000 feet, on the Raekel Glacier with Misch up to 18,300 feet, and on Nanga Parbat itself as high as 21,000 feet. He compared forms of the Himalaya with those of the Alps, noting step-like platforms, benches, and ridges especially visible in the upper Raekel and Raekel valleys. 7 distinct steps could be traced, the most marked at 13,000, 15,000, and 16,500 feet. Corrie formations above 14,000 feet gave proof of extensive glaciation, though below 7,000 feet there were no signs, unlike the Alps, where glaciers had once stretched far into the foreland. Raekel also traced 4 systems of moraines at several glaciers, evidence of advances and retreats over time, and observed a general recession of glaciers with only short interruptions. The Indus Valley itself presented a striking contrast. At 4,000 feet, it lay broad and desert-like, its gravel terraces rising in 3, 4, or 5 levels, particularly well preserved near Bunji and Bunar. These deposits suggested the existence of an ancient valley lake, later drained when the river cut through its rock dam. No signs of glaciation were found there, a sharp difference from the valleys above. Meanwhile, Dr. Peter Misch undertook the geological survey. Nanga Parbat lies in the crystalline inner zone of the Himalaya, and Misch examined its gneisses, marbles, and intrusions. He found the Massif composed of sedimentary gneisses injected by granitoid gneiss, strongly folded and compressed, their strike running from south to north rather than the usual Himalayan southeast. He noted how basic intrusive rocks, largely undeformed in their interiors, were near the gneiss, strongly foliated and mixed. This suggests a shared tectonic and crystallization history, and perhaps a younger age than once thought. Observations pointed to the possibility that Nanga Parbat gneisification might not be older than the Panjal system of the Upper Carboniferous Permian, and that the Massif might represent a zone of young metamorphism rather than an ancient crystalline block. Younger still were granitic intrusions and even tertiary or quaternary folding observed near the Indus Valley. From these intensive studies came rich collections of rocks, measurements, and photographs. Many questions would only be settled with microscopic analysis, but the outlines were clear. Nanga Parbat was not simply a climber's mountain, but a living laboratory of geology and geography. In the end, the scientific work of 1934 stood as a companion to the climbing effort. It was made possible through the organization of Willy Merkel and through the assistance of climbers who often supported the scientists on the steep slopes. Some of them never returned. The scientists expressed deep gratitude to those friends who remained on the mountain and to the institutions that had supported their work. What they left behind was more than maps and samples. It was a foundation for future research in the Himalaya, a record of one of the most detailed scientific surveys yet carried out on Nanga Parbat.